don't take your phone out. It doesn't tempt you though?
No one knows. It's like you're gonna get. Let me just. Oh, this sweater, it's like right here.
That's what happened to. Oh, his just broke off. Yeah. Well, when his first one broke and I asked Miss Everett about it, she said if it looks like they tampered with it, then we'll charge. And if we can tell it just like broke, then we'll give him one for free. Yeah, it does. I believe you, sis. I believe you. Okay. Yes. The mini review thing. Yeah. Huh? Brooke. I was at the stadium last night and I saw your little soccer thing. You know, you have a little banner of yourself.
Oh, chill.
I saw it. I was there with Miss Kay and she pointed it out to me. So you have her to thank for me noticing it.
Oh my god, it's so bad. I'm gonna rip it off.
I didn't think it looked bad. What was wrong with it? All right. Okay, so usually we would learn something new, but I have a doctor's appointment. I'm going to miss fifth today, and I could never make them learn something when I'm just totally gone. Okay, false. Actually, I would normally do that. But so we're just going to do a little review today. I'm going to run through a couple of these with you, and then I'm just going to have you work. Okay. So you do not have a new Delta math. Thank you for asking that. Okay, turn over to the back, please. We're going to do this one. All right, so first thing, I want you to go ahead and read through it, and I want you to label which function is the in, which function is the out. Okay, so read it. Okay, you have an equation here. Okay. And then you have an R of T table here. Okay, so read through the little prompt and label one of those functions is the in, one of them is an out. Okay, so we have water pumped into a tank modeled by W of T. Okay, then it says it's in liters per hour. That makes this the in function. Okay, then it says water is removed from the tank at R of T, so this is your out. Okay, notice that it is also liters per hour. Okay, then it says R is differentiable and decreasing, so we can tell the numbers are getting smaller each time. Okay, then it says select values are shown in the table above. At time 0, there are 50,000 liters of water in the tank. Okay, part A, estimate R prime of 2. Now, if they wanted W prime, I could use the calculator to take that derivative because I have the equation. But if I have a table for R and I want R prime, I'm going to have to do what? Okay, if I want R prime of 2 and I have a table, so I can't take the derivative, what are my other options? Average rate of change. Very good. Or the slope formula. So put R prime of 2 is approximated by, because remember, this is an estimation. And then what AROC interval would best estimate the slope at 2? 1 to 3. Very good. So I'm going to do AROC on 1 to 3. Okay, that would be R of 3 minus R of 1 over 3 minus 1. Let's plug in our numbers. What is R of 3? R of 3 would be the 950, right? and then minus the 119. Okay, then 3 minus 1 is 2. Now let's talk about units. Okay, R was measured in liters per hour. And 3 and 1 are times. That was measured in hours again. That didn't say hour. Okay, so if I divide liters per hour by hours again, what are my new units going to be? Liters per hour squared. Very good. Okay, then in your calculator, what is 950? Take away 1190. 240, and then that will actually divide by 2 to give me negative 120. Okay, so remember, for a table, you can't calculate the exact slope, but you can still estimate it. Okay, next part says, set up but do not evaluate an estimation for the integral from 0 to 8 of R of t. Now notice that when I have a table, okay, just like on the average rate of change, this is not going to be the exact area. Okay, trapezoidal sums and Riemann sums approximate area, just like average rate of change approximates slope. Okay, so let's do a trapezoidal sum. First question you should ask yourself is, do I have the same delta x every time, or is it switching? It's switching, so I can't do the short version. We're going to have to do the long one. So remember, it's going to be 1/2. Add the first 2 y values, which would be 1340 and 1190. And then you're going to multiply by the width between them. What is the width from 0 to 1? Delta x is 1. Okay, then next trapezoid, 1/2. What y values will I use for this second one? Reuse 1190, and we're going to add that with 950. Then the width between them from 1 to 3 is a delta x of 2. Okay, next one, 1/2. 3 to 6. What y values are we using? 950 and 740. And then the delta x from 3 to 6 is 3. Okay, and then last one, from 6 to 8. What are the y values we're adding? 740 and 700. And then from 6 to 8, my width is 2. Now, you'll notice on this one, it says you do not have to evaluate. Okay, so it says to set it up. We've done that. Okay, but you don't actually have to type it into the calculator. Okay, go down to part C. It says now use a left Riemann sum with the 4 subintervals indicated in the table to estimate the total amount of water removed from the tank over 8 hours. So we're doing 0 to 8 again. But this time we're going to use a left Riemann sum. Okay, a left Riemann sum. And for a left Riemann sum, what y value never gets used? 700, which is the last one. Very good. Remember, for a right side, you never use the first one. So go ahead and set that up. Remember, it's width times y value, width times y value, width times y value. So my first width from 0 to 1 is 1. My left y value is 1340. My next width from 1 to 3 is 2. My left y value is 11. What's my next width? 3. My left y value is 950. And then from 6 to 8, my width is 2. We're using the 740. Okay, remember the 700 never is part of the process because it's the last y value on a left Riemann sum. Okay, go ahead and put that into your calculator. Okay, did y'all get 80/50?
Yeah.
Okay, good. Now, let's talk about units. You just integrated something that was originally liters per hour. So if I do an integral on liters per hour, what is this measuring? Liters, very good. And then you would just go back into the story and say, okay, these 8,050 liters are the amount of water. Okay, and then this is water removed from the tank. And then it would be over 0 to 8 hours. Okay, so we should be relatively comfortable with putting those little explanations in. Okay. Then I kind of ran out of room, but it also asks us if this is an overestimate or an underestimate. So I want you to think about the type of numbers, okay, that we see in our chart. Are they overall increasing or decreasing? Decreasing. Okay, so I'm going to draw a little baby sketch right here. So if I have a graph that's decreasing, and I cut it, let's just cut it into 2 pieces, okay? So remember, we're estimating area. I'm going to cut this area just in half one time. So I have 2 pieces. And I'm going to use which end to do my room on sum? The left side or the right side? The left side. So my left side determines the height. My left side determines the height. Are my rectangles too big or too small? They're too big. So let's do, this is an overestimate. And then I'm going to put because we used the left Riemann sum on a decreasing function R of t. Okay, but remember the over under has to do with did you use left or right, and also was your function increasing or decreasing in the table. Okay. All right, last little part of this. It says, use your answer from part C to find an estimate for the total amount of water in the tank. Okay, so we covered this before y'all's last test, but I just want to remind you of how to do it. Remember, we have an in and an out. So how much water was already in the tank? Go back and read if you forgot. Okay, there was already 50,000. Okay, and it says that in the last sentence of your prompt right here, that at time 0, there was already 50,000 liters. Okay, then I need to add the water that came in from 0 to 8. Will I use W of t or R of t for the water that came into the tank? W of t. And for W of t, I have an equation, so I'll have to use my calculator for that part. Okay, then I'm going to minus the integral from 0 to 8 on R of t. Okay, because remember, this is my in, this is my out. Okay, so in your calculator, okay, go ahead and type in your equation to your Y1. So it's 2,000. Okay, and then hopefully you can read that. Okay, then remember, it's math 9 for an antiderivative. Did you call me? Oh, okay. All right. Okay, thanks. Bye. You too, bye. It should be 2,000 e to the power of negative x squared over 20.
Oh, okay.
Oh, yeah, so you just use an x. Okay. Then from there, we're going to math 9 it. We're going 0 to 8. Remember, it's alpha trace y1 dx. Okay, so our answer came out to 78.36. Now, it does say to round to the nearest liter, so that would be like a whole number. So if it's 7836.1, I'm gonna keep that number the same. So it's 50,000 plus 7836 and then minus 8050. Okay, so remember, we did this integral in the calculator because we had the equation versus this integral, we had to use our answer for the Riemann sum because we can't actually do it without the equation. We can only estimate it using the table. Okay. Question? That was our answer from here. It says it in the question. If you look at the top, at time 0, there are 50,000 liters already in the tank. So remember, you want to start just like with your final position. We need to know what's the initial position and then start from there and add to it. So that's going to be the same kind of deal here. Okay. And then if you want, you could go ahead and add those numbers. Okay, final answer would be 49,786. That was our answer from right here. Okay, and then this was the initial amount already in the tank. Okay, how do we feel about that? Feel good about it? Okay. All right, so then I feel like you should be able to mostly do the first one. So let's go ahead and skip to a couple of the fundamental theorem questions. So let's do this one. No, this one. Change my mind again. This one. All right, you're doing an integral and you have endpoints. So first thing you're going to do is take the antiderivative. Can you tell me the antiderivative of 3x plus 4? Say it again, 3 halves x squared, and then plus 4x. Now remember, technically the plus c's there, but nobody cares about that. Okay, because we know that once we plug in the endpoints and subtract, the c's are gone anyways. Okay, capital F at 5. Then we'll do capital F of 3. And then we'll subtract those two. Let's do 5 first. What is 5 squared? 25. Now times it by 3. So this is 75 over 2 plus. Okay, now we're plugging in a 5 here. What's 4 times 5? 20. Okay, and just leave it like that. Okay, I'm not even going to put the C because I know it's going to cross out anyways. Now we're plugging in a 3. What's 3 squared? Times it by 3. 27. Now, if I could divide it by 2, I would do it. But since I can't, I'm just going to leave it as a fraction. Okay, then I'm plugging in my 3 here. 4 times 3 is 12. And then remember that when you subtract, if you have a fraction, subtract it with the other fraction. And if you have a whole number, minus it with the other whole number. So what is 75 halves minus 27 halves? 48 halves, which can be cut in half to give me how many? 24. Okay, but then also remember, you got to subtract these two. So 20, take away 12, 8, and then you would add those two numbers together. Okay, but it's this minus these, this minus that. Okay, which would give me a total value of 32. Okay. One other one to do like that. Let's do the first one on this row. You have a 2 over x, that's a special. What's the integral of 2 over x going to be? ln x. Very good. Now specific, where does the 2 go? 2 in the front. Very good. So it'll be 2 ln x and then plus c. We're going to plug in the 20 and the 4. Plug in the 2 first. What am I, or sorry, the 20 first. What am I going to get? Don't put it in the calculator. Just what would the answer be? Exact value.
49.
Yeah, it'd be, hold on. The 20 goes here. So it'd be 2 ln 20, right? Okay, and then plug in for an x. It'd be 2 ln Okay, then we're gonna do this minus that, so top minus bottom. So my answer is gonna be 2 ln 20 minus 2 ln 4. Okay, now, if they both have a 2, what can I do with that? I could just GCF it out to the front, right? So this would be the same as 2 ln 20 minus ln 4. Are we good to there? Okay, then in the notes, when we covered this, we talked about logs have some kind of weird rules. What do you do with logs that are subtracted if you want to simplify them into the same log? Divide. So if it was this log plus that log, to put them together, you'd multiply it and get natural log 80. But if it's a minus, you divide these. So what's 20 divided by 4? It'd be 2 ln 5. Okay, so remember, in pre-cal, you should have learned all those rules. Hopefully you did. Okay. All right, let's turn the page again for me, please. Let's do one of the bottom ones. Let's do the first one on the bottom. All right, so you have a graph, okay, and you should have done this on your homework, but it says in the little prompt, okay, that the numbers in the pockets are how much area is in that pocket. Okay, so you're asked to find what is the value of the integral from -6 to 5 on the function f of x plus 4. Okay, that's what you're asked to calculate. Now, keep in mind, this is a graph of f, okay, but for the plus 4, I'm going to have to separate these into separate pieces. So I'm going to do -6 to 5 on f of x, and I'll use the graph. Then I'm going to do -6 to 5 on the 4 separate. Okay, let's do the graph first. Start at -6. You're going to stop at 5. And remember, any area below counts as what? Negative. So in your calculator, type in, you're going to accumulate -11 plus 7 minus 4 and then plus 10. So -11 plus 7 minus 4 plus 10. What's our net change in area? 2, yeah? Okay, good. So this came from the graph, but then for 4, I would have to do fundamental theorem on it. Or if you want, you could graph what y equals 4 looks like and then calculate the area by hand. So what's the antiderivative of 4? 4x plus c, very good. And then I would just plug in the endpoints and subtract. So capital F of 5, capital F of -6, and then take away. 5 first, 4 times 5 is 20. What about 4 times -6? -24. And then remember, it's this minus that. So if you do 20 minus -24, what's it going to be? 44. And then you would take those two answers and add them together. So remember, if it's a plus or a minus, like it is on this one, okay, you're going to have to find those two separate answers and then either add or subtract based on one side. Okay, so 46 would be your correct answer. Okay? Make sense? All right. Let's do one more off the next page and then I'll just give you some time to work. Let's do next page, this one. Okay, if you read at the top of the page, it asks you to find average value. Okay, and average value is a formula. Remember, it's 1 over b minus a, integral a to b on f of x. Okay, so you're just basically going to do the integral, but then don't forget in the front, you need to divide by 1 over b minus a. So if I was doing this one, okay, it says I want absolute value f of x, Okay, and I want it on 0 to 5. Then my average value is gonna be 1 over what? What would my b minus a be here? 5 minus 0, and then integral 0 to 5. Now, my equation this time, it's not f of x. What does it say? Absolute value f of x. And remember, absolute value means I'm going to treat every single area as what kind of number? Positive. So if I start at 0 and I go forward till 5, remember all of these count as plus. So 4 and 10 makes 14. So it'd be a fifth of 14, which is 14 fifths. Okay. Go ahead and do it for the one right next to it. What would the 1 over part be? 1 over 5 minus negative 3. And then integral negative 3 to 5. Remember, 5 minus negative 3 is really a plus. So what is my number in the front there? 1 over 8. Very good. Okay, and then if the absolute value bars aren't there, you'll accumulate the area from negative 3 to 5. But remember, count their areas based on where they're accumulated. Okay, so from negative 3, that'd be here. So I'd have 7 forward, 4 backwards, and then 10 forward. So that'd be 17 minus 4 would be 13. And then if you can't actually divide it, you can just leave it as a fraction. Okay. All right. Can you kind of glance through it? Do you think you need help with anything else? I just noticed the back side of this is a repeat. So if you just want to scratch it out, this is the exact same as the front page. On the back side. That's just the front again. So. Anything else you need help with? I love to help. I will do it with you, but I'm not going to make this period watch the whole video. I'd love to. Do you think you can do these two? Do you remember how to do the meaning? So for this one, it's the same. What about if it has a 1 over in front of it? Do you remember the difference? So R of T is measured in what here? Gallons per minute. Then when I integrate it, what's it going to be? Number of gallons. What about if I 1 over B minus A it? Still gallons per minute. Very good. Okay. Okay. All right. Good luck, 5th period. You can do it.